So the cool thing about my new setup is like, look, we're right there. Right there, that's Mel. She's sleeping. Shh, she's sleeping. We gotta do logarithms. We're gonna take a look at the properties of logarithms, and we're gonna be solving some logarithms as well, and exponential functions. So we'll be doing the both of those. So a quick overview of all the different logarithmic functions. You want to remember that the logarithmic properties are the same as the exponential properties. With exponents, if you multiply, that's the same as adding the exponents together. When you are dividing numbers with exponents, that's the same as subtracting the two exponents, because logarithms and exponentials are related to each other. There's also the change of base formula. I downplayed this in pre-calculus. You can use it if you want. What you need to do is what's inside of the logarithm and divide it by the logarithm's base. You could also say, hey, the base has got to be on the bottom of the fraction, whatever you want to do to remember that. If you want to use it, you don't even have to use it. So we want to use these inverse properties to simplify this thing. So we've got a logarithm with its base put into it, because the base of natural log is e. So that thing just sort of cancels itself out, and we're left with, can I have a pen, please? Just whatever the exponent is, which in this case is x squared. Now we can use these properties in little goofy ways, where if I'm trying to find the natural log of 6, sure, I could type that into my calculator, but it's given me a couple things. So let's do some tricks. I know that 6 is 2 times 3. And since it's inside of a logarithm, I can break that up into two separate logarithms added together, ln of 2 plus the ln of 3. So I know what those are. They're up here. So I can just, sorry, my phone made a noise or something. I can just add those two decimals together, and then I know what the ln of 2 plus 3 is. It would be, let's see, 7, 1, that carries, and that carries, so I think it's 0, 8, 1. Oh, she's popped up. Oh, she's real excited. She wants to help. In the next one, we want to change that thing into an exponent, ln of 3 to the 1/2, and then we can bring that exponent in front. So 1/2 of the ln of 3, which is 1.0986. And then we just got to cut all that in half. So that's 5, this is 45, and then 9, and then 3. I might have done that slightly wrong, but you know what I'm doing. I'm taking the decimal and cutting it. She left. I think she just wanted to yell at me for talking while she was sleeping. She's like, I'm trying to take a nap. Why are you talking? In the next one, I want to get that thing out of the exponent. So I'm going to take the natural log of both sides in order to get that thing out. So then the x plus 2 comes in front. We've got an ln of e equals the ln of 8. So the ln of e, that's just 1, so it's gonzo. We got to subtract 2, so x is exactly, I'm going to do -2 plus, so it doesn't look like it's inside of the logarithm. -2 plus the ln of 8. Let's do that on Desmos. So we get 0.079. We're going to solve this equation algebraically, and we're going to support our solution graphically. And I'm going to do this a little bit backwards. Since we're going to look at that graph, I'd like to know what the answer is already, so that I'm kind of prepared for when I get my actual answers. So I'm going to go into Desmos, and I'm going to type this thing in. So we can see our two spots. We just care about where it equals 3. So my two answers should be -0.962, and my other one is +0.962. So I should get positive and -0.962. What I want to do first is I want to get those e to the x's matches, and you'll see why e to the x's to match, and you'll see why in a second. So I'm going to get e to the x plus, and this e to the -x, I'm going to convert it into a fraction. The reason I want to do that is I'm going to use a substitution trick. So e to the x, I'm going to get sick of writing over and over and over again. So I'm going to substitute those for y's, and that'll make it a little bit easier for me to work with this problem. So I'm going to replace those e to the x's with y's and then continue solving my equation. It just kind of cleans it up a little bit. So the other solving things that we're going to be doing will be a little bit easier. We actually use this for derivatives. There's a u substitution form of derivatives that we do for calculus. So we're kind of practicing that right now. Now that I've got these, I want to get those two fractions put together. So I'm going to make that a y squared over y plus a 1 over y equals 3. Whoop. So we get y squared plus 1 over y equals 3. I'm going to get rid of that denominator. So I get y squared plus 1 equals 3y. We get y squared minus 3y plus 1 equals 0. And unfortunately, this one we can't factor. So in order to solve this thing, guess what we're going to have to use? Oh, it's time for the quadratic formula. Yeah, I haven't done that in a while. So quadratic formula. 9 minus 4, which is 5. All over 2. So let's go to our calculator, type that in. So we get 3 plus, I need a square root. So I get 0.381 and 2.681, which you might have noticed when I said, is not my answer. But I was supposed to be getting, what were our points again? It was negative 0.962, but we didn't get that. Well, remember, this is what y is. It is not what x is. We were trying to solve this thing for x. Remember, we replaced those y's with e to the x's. So we need to go back into that. 2.618. So in order to solve this thing, we need to take the natural log of both sides. So let's do the natural log of that answer. And there we go. There's our 0.962. We also need to do the other one. It'll follow that same process. The ln of 0.381. And hopefully it should give us our positive one. Yeah. Well, I'm sorry. We already had our positive one. There's our negative one. So the natural log was getting both of those answers. So we got our plus or minus 0.96. Yeah, that's about it. So a reminder, you've got all of your sweet logarithms rules. You can use them to manipulate and move things around as you need. You need to make sure that you're keeping all these rules straight. They're the same as the exponential rules. Keep in mind the change of base formula, it's helpful, but it shouldn't be like your safety switch. It's something that you can do, but it usually ends up making more of a mess. So I try to avoid it, but we'll see. I don't know. I haven't done calc before, so it'll be something new. So thanks for watching, and catch you later.